Hello everyone, I'm Lee. In this video, we're going to revisit the address book application we wrote before. We're going to change the internal implementation for two classes, the one class address entry and another one entry list. And we will be very careful. We only change the private data members and we change the implementation. That means because of data encapsulation, the clients don't need to change their code. So that's the beauty of object-oriented programming, and that's why we use data encapsulation. When we change the internal data representation and implementation detail, the client don't need to change their code. So I'm going to make two changes. The first one is in address entry. Instead of using static array, we use like a fixed length array for name, fixed length array for email. We are going to use a dynamic array. So that means for each address entry object, the name array is going to be just big enough for a specific name. So for example, if the name is Connor, Connor, then the array should be just 7 characters, 6 characters for the name and 1 extra character for the node terminator. Okay, so that's one change we're going to make. And another change is how to represent this list. We are going to use a dynamic array. And the reason about dynamic array is later on, if we got more entries, we can still handle it. For the static array, it cannot grow. For dynamic array, it cannot grow either, but we can fake grow. You will see. Okay, so let's first take a look at address entry. How do we make this change? So right now, after we make the change to make name and email to just pointer to char, there's no array yet. So let's take a look at the implementation. So one big change is in the constructor, because name, it doesn't have the name array yet. So you have to allocate that array. So assume if they didn't give you any name, we use no name. So we first run string length to get the number of chars in this string, then add 1 to the node terminator, then we do the string copy. Same thing for email. And for another constructor, they have the name and the email passed in. So, and we do this pointer name because we got the naming conflicts here. So we got the name as a local variable and the name as the instance data member. So to make the difference, we say this big arrow name. This is a pointer to the current object. That's why we use the big arrow. And then we allocate just big enough for the name, then do the string copy. Same thing for email. And now let's take a look. We introduce destructor here. So constructor get invoked when the object get created. So we use constructor to initialize the initialize the state of the object. Destructor is on the opposite. Destructor get invoked when the object's lifetime is over. So that means when the object lifetime is over, this destructor is going to get executed. So for every object of address entry. So we did the new in the constructor. We're going to delete the name in the destructor so that we don't have memory leak. Memory leak means when you knew something, you forgot to deallocate it, because the new get executed at the runtime. If you don't delete it, it's going to become memory leak. Okay, so that's a destructor. Pretty much that's a change, because we only modify the internal data representation and we only modify the implementation detail, the CPP file. So the client of address entry, which means entry list and test address book, they shouldn't be modified because we didn't touch the public interface here. And for the implementation of address entry, another function that need to be modified is the set name. So when you change the name for this address entry, you need to first delete the existing array and then allocate a new one, which is just big enough for this new name, then do the copy. Now let's take a look at entry list.h. So right now list doesn't have an array. So in the constructor, let's take a look at the constructor. constructor. constructor 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 construc the default constructor, we're going to allocate some capacity here, and this capacity, I initialize the capacity using some constant variable, but you can pass in an innate capacity here in another constructor. So we allocate the array, and we make sure the size is 0. That means it doesn't have any elements in it, but the array is there. And for the other constructor, actually I did change the user interface here. I add this feature, passing an integer, a preferred capacity, so that we can use that one to create an array. And initialize size and load the address book from this file. And again, here's a destructor. When the list lifetime is over, it's going to deallocate the list. Otherwise, you got memory leak. Okay, and another implementation change will be the add function. For the add function, for the previous implementation, if the size exceeds capacity, then you simply cannot do it. But now we're using dynamic array, we can expand the list somehow. Okay, let's take a look at how to expand the list. So this is where we fix the growth of the list. You cannot grow the existing array, but you can fake it. So take a look. So first double the capacity, then I create a temporary array with this double sized capacity, then copy over the contents from the original array. Then delete the original array, otherwise you got a memory leak. Then make the list point to this temp list. For the static array, we cannot do this because the array name for the static array is a constant pointer. You cannot point to anywhere else. But this is dynamic array. You can make this change. So that's the only difference in implementation. And again, the client code doesn't need to be changed. But in our case, we introduce another constructor. This constructor will take in an innate capacity, so the client code does need to be changed here. So in order to test the expand function, I put a size 1 there so that I can test it. Okay, and in the testing code, this is one difference, and another one you might be curious about. This is the memory leak detection tool in Visual Studio. So you can just copy paste those ones, those header files, and put this line as the first line of the main function. So that's how you enable memory leak detection tools. And when you run it, you need to go to this one, say start debugging instead of start without debugging. When you do start debugging, let's see. To a listing and quit. You see, it didn't say anything here. That means you don't have memory leak. So no news is good news. So if we have memory leak, for example, if I do something like this, if I say, how about in the destructor, I comment out the destructor, so we just don't deallocate the array, then you know for sure there's going to be memory leak. So let's take a look at this one. And you see here it reports detected memory leaks. Okay, so that's how you use the memory leak detection tool. Thank you.